Okay, last video we talked about converting polar to rectangular. Again, if we superimpose the polar plane on top of the rectangular plane, what would this polar r comma theta correspond to in terms of an x and a y coordinate? Where would that location be in the Cartesian coordinate system? Well, obviously we should be able to go the reverse direction. In other words, if I give you a normal x and y coordinate in the Cartesian coordinate system, what would that look like if you superimpose the rectangular coordinate system on top of the polar? In other words, what would the r and the theta be correspondingly? Well, going backwards, again, you're not going to be surprised. We do have to use some trigonometry here. So the situation in this case is I give you an ordered pair, x, y. And, let's not even go generic here. Let's just say I give you a point 3, 2. No tricks here. Just plot the point 3, 2 on the Cartesian coordinate system. So here's 1, 2, 3, 1, 2. There's a point 3, 2 if I plot x and y, like we did back in algebra and pre-algebra. Right? Real simple stuff. Now, more complicated question, what would be the corresponding r and theta if I were to turn these on the x-axis, pretend this is the polar axis? Like I said, this is very dangerous stuff. Okay. Let's try to do this. We're going to even need a force circle, maybe. I don't think it's supposed to hit that force circle. The question is, where would this point be if you put the polar plane on top of the Cartesian coordinate system? In other words, what would the r and the theta be? Well, if I go back to my original graph here, this one's kind of messed up now. 1, 2, 3, 1, 2. If you knew your x coordinate, say it's right there, and you knew your y coordinate, would you be able to figure out your r and your theta? So in this case, I don't even know why I'm saying x and y. We know exactly what they are. That's 3. This is 2. Question is, can you figure out your r and your theta? Well, what is r? R would be the circle you're on, the radius of the circle you're on, or, in other words, the hypotenuse of that right triangle. So to figure this guy out, it's simply use the Pythagorean theorem. Take your x coordinate, square it, take your y coordinate, square it, take the square root of that, and that should be your r, the hypotenuse. R is equal to the square root of x squared plus y squared. That should not be a totally unfamiliar formula to us. We use this a lot when we were finding the exact value of the 6 trigonometric functions of theta. Right? So to figure out your r coordinate, if you have your x and y, it's just the Pythagorean theorem. That's all it is. Now, a little bit trickier. To figure out your theta, again, there could be multiple thetas here. We're going to go with the simplest one. To figure out that theta, you say, okay, all I have to go on is my x and my y coordinate. My x is my adjacent. It's adjacent to theta. My y is opposite of theta. So if you think about the trig ratio, the easy one that uses opposite and adjacent, that would actually be tangent. So to figure out that angle theta, you would say that the tangent of theta is equal to opposite over adjacent. 2/3. Now, how do we solve that? Well, last chapter we learned you got to inverse tangent both sides. So theta is the inverse tangent of 2/3, which is, I don't know. I didn't figure out the radius. This would actually be how we would figure out the measure of that theta, and this would not be a pretty one, of course. We would approximate that to 1 or 2 decimals, whatever the directions asked. but this is how we're going to figure out our theta. So how do you figure out your r? Pythagorean theorem. How do you figure out your theta? Inverse tangent. Slight problem though. That is the functional inverse tangent. And this can only give you answers in Q1 if it's positive, which it would be, and we'd be fine with that. Or if it's negative, it would give you a Q4. Well, my question to you is, what happens if we're in quadrant 2? I mean, what if I would have picked an ordered pair as -3, 2? What do you do then? Because this sure is not going to give you your correct answer. What it's going to give you is a reference angle, right? And we'll see how to fix that when we actually write out these formulas. But this is the idea. So let's put it all together. All this stuff, I'm going to need the space. Put all this stuff together, and this is going to be how we're going to convert from a rectangular xy to an r theta. All right, so let's put it this way. To convert a rectangular coordinate that is x comma y to a polar coordinate. In other words, its corresponding polar location to a polar coordinate. That is r comma theta. We're going to use the following. Okay, let's first of all figure out how we're going to do our r. R is pretty straightforward. It's going to be from the Pythagorean theorem, literally r squared equals x squared plus y squared, or r is equal to the square root of x squared plus y squared. Now you notice if we go with this formula, we will always, always, always have a positive r for our answer. We'll never get a negative out of this. Right? So r will always be positive when we convert this ordered pair xy, whether those are positive or negative, into r theta. I mean, that's not a big problem. In fact, it makes things a little simpler. Now, theta, on the other hand, a little tricky. Theta, we can say, is simply going to be the inverse tangent of y over x. Under a condition here. Tangent inverse of y over x if you are in quadrant 1 or quadrant 4. So if this point is in quadrant 1 or quadrant 4, then we just simply say it's the inverse tangent of y over x, because that's where this is defined, quadrant 1 or quadrant 4. Now you say, okay, how do you know? Well, you can tell totally by your x-coordinate. Your x-coordinate, when it is positive, you will always be in either quadrant 1 or quadrant 4, regardless of what the y-coordinate is. So you're really just focusing in on that x-coordinate. If x is positive, you're good to go with inverse tangent. If x is negative, you're not so good to go with inverse tangent, because it's not going to give you a quadrant 2 angle or a quadrant 3 angle. It only works in Q1 and Q4, so it's going to need a little help. You will still do tangent inverse of y over x, but it needs a little help to get to the other quadrants. If you're talking a quadrant 2 angle, you need to add, or quadrant 3 for that matter, you need to add 180 degrees to this to get the true answer. So if you are in quadrant 3, for example, let me just give you a quadrant 3 point. So -4, -1. And you want to know what your theta is in polar coordinates. Well, if you just simply do the tangent inverse of y over x, -1 over -4, you can see immediately that becomes positive 1/4. And this guy doesn't know that you want quadrant 3, not quadrant 1, which is what you're going to get. So when you do the tangent inverse of 1/4, you're going to get a quadrant 1 angle. Well, what we're saying is, it's basically saying, oh, So you wanted the point for positive 1 because that's actually what you're getting. You're saying, no, we actually want the point that is, dare I say, diametrically opposed to that point. Angle-wise, it is 180 degrees away from the actual answer. So if the x is negative, you do have to add 180. And likewise, if you had a quadrant 2-point, like let's say negative 3, 1, your calculator is going to think, oh, you wanted 3, negative 1. Like, no, I want something that's diametrically opposed. So you're adding 180 if your x is less than 0. So if your x is a negative, then you do have to add the 180. Now, there's other issues here. What if you're quadrantal? Quadrantals can be drawn out and figured. So you do have a problem when your x is actually 0. When your x is 0, then you have to appeal to your y coordinate. And you can know where you're at. So if I say, what if x is 0? And then y is negative 3? Well, it doesn't take a whole lot of detective work to figure out where we're at. Where is 0, negative 3? Well, 0, negative 3, you could call it negative 90, or you can call it 270. It's not that big of a deal when it's quadrantal. Simply draw it out. So if your x is 0, yeah, you're in big trouble with tangent inverse because that is undefined. So a simple picture will indicate what your angle is. So don't panic when you come up with x equals 0. Right? We'll see some examples in that last